I'm very pleased to announce that our new eye tracking engine, which we call ETV3, has already been publicly available for some time now, but only fairly recently has it become the default choice. We spent a great deal of time creating this new solution. Thanks to that, study participants will experience a completely new level of quality. Calibration takes just a few seconds, and users can behave much more freely in front of the computer. When we were running studies and testing various things, participants had to stay in one fixed position for several, even a dozen or so, minutes, and that became quite tiresome. Calibration, which in the previous version of our solution required almost 40 calibration points. With our new solution, we're able to launch an eye tracking study after collecting just 4 points. When we started this project, version 3 of the tracker, our goal was to maintain at least the same accuracy and precision that we had already been offering our clients, because they were happy with it. We knew we were satisfied with it too, and that it allowed for most of the studies our clients wanted to run remotely. What we're really pleased with is that we managed to maintain that same accuracy in the new solution as well, even though the user can now behave much more freely in front of the computer during the study. After about 2 years of the platform running really well, with many clients on board, we still felt a certain dissatisfaction because participants didn't feel entirely comfortable taking part in the study since they couldn't move around as freely as they'd like. Calibration also took longer, and of course, every participant gets paid for taking part in a study. That payment usually depends on how much time someone spent taking part in the study. And if the study itself takes, say, a minute, but calibration also takes a minute, then shortening that calibration time would translate directly into significant savings for our clients. That's another thing we wanted to achieve, knowing that our current solution needed almost a minute, roughly a minute, to calibrate. And after looking at the competition and various academic solutions, we concluded it was most likely possible to shorten that calibration down to 25 to 30 seconds. After a number of experiments, we also came across information that a new round of grant applications was opening up, supported by the European Union. At first, we had some doubts about whether this was even the right project for us. And it turned out that after many months of working on the application, refining it, and waiting for results, we succeeded. The goals definitely included the duration of calibration, the ability to use the device more freely on which the eye tracking test is conducted, meaning gentle head movements, as well as maintaining or perhaps even improving the accuracy and prediction of eye tracking. And we managed to achieve all of these goals. Thanks to the fact that the entire eye tracking engine runs on the computer, on the panelist's own device. No image is ever sent to servers with powerful computing capacity. The whole solution had to run smoothly even on older hardware, laptops and phones several years old. And that's where fitting a machine learning model in was quite a challenge. Because while creating a solution that met all our criteria, fast calibration, good accuracy, and handling the panelist's movements in front of the camera, the first, most powerful version of that model would have required running it somewhere on cloud servers. As a result, we wouldn't have been able to offer a solution that protects participants' privacy to such an extent, because the image would have had to be sent to that server.
Dlatego tutaj musieliśmy znaleźć złoty środek.
So we had to find a middle ground, how to lower our solution's hardware and software requirements
naszego rozwiązania, tak
so that it would run on average
na
devices
przeciętnym sprzęcie, dostarczając
while
przynajmniej
still delivering a sampling rate of at
drukowanie na
least
poziomie
30
30
Hz.
herców. I to
And
się
after quite a
udało
few experiments,
po iluś tam
we managed to pull that off.
eksperymentach. Aktualnie ten model, którego używamy,
The model we currently use was trained on sessions collected from over 5,000 people on different devices and under different conditions.
w przeróżnych warunkach. Oczywiście staraliśmy się, żeby działało to.
Naturally, we made sure it would work well for people from all over the world, of different ages, races, and genders, on different devices. Since, of course, everyone has a completely different laptop, or uses a webcam attached to a huge monitor or a small phone. A single person would provide us with around 200 samples, so at this point, we genuinely have hundreds of thousands of eye tracking samples. That much training data was needed for the model to learn how to effectively predict where someone is looking on the screen under a variety of conditions. Since our eye tracking platform never sends us any images from participants, it was fascinating to finally see the conditions in which they actually use our platform, the conditions they sit in when taking part in an eye tracking study. It was an incredible experience because these are truly people in their most natural environment, at home, sometimes in a cafe, at the office, in the evening in dim light, or at night, where the monitor is the only source of light at all. For us, that was a moment when we gained even more respect for our current solution, seeing that it's able to handle such difficult conditions. One thing I think is worth mentioning about this project is that we managed to crown it by deploying it, of course, into our eye tracking platform, RealEye.io. But along the way, a project called Reconnect was also created, which uses this technology too. It's a project that helps people with conditions that prevent them from moving or speaking to link letter boards or text on their laptop and, using just a regular webcam, communicate with their loved ones and their surroundings, thanks to our eye tracking technology being able to reliably determine where they're looking. So that's really exciting. We've already gathered a lot of data from the new eye tracker, and we can see that everything's working very well, so that's great. But, as is often the case, appetite grows with eating. So we keep trying to improve this technology to squeeze even more out of it. Right now, we're very happy with how it performs on laptops and PCs. We'd still like to fine-tune how it works on smartphones and tablets. We're also considering refining and delivering something on a whole new level when it comes to facial coding, and we'll be working on that for a while yet.